Right, in our previous class, we started learning this network type in OSPF, and we saw how point-to-point and multi-point behaves. We also learned that there is one more called non-broadcast, which is default on our frame relay interface. Not only frame relay interface, if the encapsulation here is frame relay or ATM or X.25, it's going to be non-broadcast. Now, none of these are seen. I cannot say that frame relay is seen somewhere here and there, but other two are not seen anywhere. These are very old technology. Now, the moment you put OSPF on this port, where encapsulation is one of this protocol, then the OSPF network type is non-broadcast. We learned that non-broadcast is default. We learned the timers are 30 and 120. We learned that all the members participate in this should be in same subnet. And there is going to be a DR, BDR election. So, so full mesh is recommended for this. Full mesh. Hub and spoke is not the right topology for this non-broadcast type. Full mesh is recommended. And one more very important point we learned is neighbors are not dynamically discovered. So neighbors are manually configured. Manually configured. So if you will have a full mesh and you do not want the neighbor to be dynamically discovered, and when all the participating routers are on the same subnet, you may go for this. What are the other options? There is another option called point to. This also we saw. Point to multi-point. In this, see, for this one you have to you need to change the network type. This is default. You don't need to change. But if you want this one over these encapsulation type interface, then you need to put the command and say, I want point to multi-point. When you do that, neighbors are going to be dynamically discovered. And the timers are same, 30 and 120. And all the members should be in same subnet. That is also same. And no DR, BDR. Wherever the word point comes, then point to point, no DR, BDR. Point to multi-point, also no DR, BDR. Wherever the word point comes, you should be sure that there is no DR nor BDR. And because there is no DR or BDR elected, this is a nice network type for hub and spoke. For hub and spoke, there is no need for DR, BDR. So you may go for this if your topology is hub and spoke. Doesn't mean that you don't need to, you should not go for full mesh, doesn't matter. You can have full mesh or hub and spoke. You may go for this, but this one is recommended only for full mesh because there is DR-BDR. Since there is no DR-BDR here, it can fit in any network design. Now, these two are industry standard. You will find in RFCs, you will find these two modes, network types, supported by every OSPF appliance. Now, we are going to see other three, which is only seen in Cisco. What is that? Point to multi-point. Why are you writing the same thing again? No, it's not same thing. Point to multi-point. Non-broadcast. It looks like I put the previous two network types together. Yeah, that's what Cisco has done. Uh, they came up with this new network type, the third one called point to multi-point non-broadcast. It's one network type, point to multi-point non-broadcast. You may think like, but I understand non-broadcast. I understand point to point. What is that point to point? At the same time, non-broadcast. The reason why they named like this is they have taken the best of both. The best in the first one is neighbors need to be manually configured. Now, how can this be a best? For a routing protocol, discovering neighbor is what we expect. No. Routing protocol is to distribute route information. As a bonus, we were enjoying the privilege of having neighbors dynamically discovered. See, forming neighbor dynamically is not safe. So, if you think that way, I don't want my neighbors to be dynamically configured, dynamically discovered. I would like to manually configure it so that I will have a control over the adjacencies. If you feel so, this is the best one. Neighbors are manually configured. At the same time, no DR-BDR election. That's why, the name together. See, no DR-BDR, we learned from the second one. Neighbors are manually configured, we learned from the first one. So this is the best of both point to multi-point non-broadcast. Neighbors are manually configured, no DR-BDR, and the timers are same 30 and 120. Same subnet. Because the adjacency is not going to form DR or BDR, no DR-BDR election, this fits in any topology. You may have partial mesh, full mesh, or hub and spoke. Any topology. Okay. Now there is two more what Cisco has brought. It is useless actually today. Only if you have, see these three modes that you learned, you can go and configure here also. No problem. Sniffing. By default, this is broadcast. Neighbors will be dynamically discovered. DR-BDR will be there. 10 and 40 is the timer. If you don't want this, then you may go with one of this, which you learned now. If you like this one, then go and configure non-broadcast. If you like this one, then go and configure point to multipoint. Or if you like this one, go and configure point to multipoint non-broadcast. When you change the network type, the behavior will be as we saw here. Even though we don't have frame relay, we can have the benefits of frame relay environment. Even though this is really a broadcast environment, you can get the advantage of the frame relay environment. But what I'm going to show now is not going to be used unless you have frame relay. Let's say you have frame relay, the real frame relay, and you are connected to multiple sites. These are serial wires. This is frame relay. In frame relay environment, in frame relay scenario, if you wish to have a normal broadcast experience, though it is frame relay, you want to have this Ethernet experience. In that scenario, in that situation, you can go for the network type called broadcast. Yeah, you can go and configure here broadcast. When you configure broadcast, it will start sending hello packets 10 second over the frame relay. 120 second, no, 40 second. Usually on the frame relay, it is 30 and 120. But now, because you have made it as broadcast, over the frame relay, it is just giving you the experience of Ethernet environment. Whatever you used to see in normal broadcast environment, you will see here also. You will see here. You will have DRBDR election. You will have timer like this. All should be in same subnet. You know. So if you wish to have a frame relay experience here, you can go for the 3 modes which we learned. But if you want to have an Ethernet experience over the frame relay, you can go for this network type. The fifth one is point-to-point. When do we need point-to-point? When we have different subnet. For example, here I have 192. Here I have 172. Now my 2 remote sites are not in same subnet. If they are in same subnet, I would have gone for broadcast. But they are not in same subnet. So what do we do? We create 2 subinterface on the hub router. Let's say serial 0.1. This is serial 0, physical interface. Serial 0.2, point-to-point. And we give IP address 192.168.0.1 here. And we here give 172.16.0.1. And we configure the OSPF network type on each subinterface as point-to-point. Though it is a frame relay environment, you will get a point-to-point experience. In point-to-point, we don't have DRBDR. In point-to-point, this is a timer. In point-to-point, neighbors are dynamically discovered. From router 5, which I just added, I'm trying to ping 3, 10.0.0.3, okay, 10.0.0.4, okay. Let's check, sometime if we don't have proper subnet mask, this problem maker. Show IP OSPF. Yeah, but it keeps dumping it. Okay, show IP OSPF interface brief. I can see the mask here is 8. Okay, that's fine. What did we route it to? Show IP OSPF interface brief. Mask 8. Right. Show IP OSPF interface brief. Okay, the reason why it is flapping is in the previous class we configured point to point. But is this real point to point? No, it's multi-point. That is why. So let us go to router 3 and make it remove what we configured. On interface of 00, when I say and no IP OSPF network type point to point, okay, I simply cancel this. It will remove whatever it is, whatever it was configured. Also, I'll do the same on router 4. Yeah. So how do I know the problem? I just noticed this P2P, yeah, under the interface. When I typed show IP OSPF interface brief, I was able to see that here. On R5, when I checked the same command, it was not P2P. All right, so now it won't flap anymore. Hopefully, show IP OSPF neighbor. Okay, it's in two-way state. Did I set any? Let me go to the interface straight and see. Show run interface F00. No priority set. Good. Yeah, I don't think it will flap again. That's all. Okay, no more flapping. Where are we? Let us check whether we have neighbors now. Show IP OSPF neighbor. Yeah, we can see router 5 is the DR. That's why we are not seeing that in the list. We are already on router 5. Router 4 is BDR. And router 3 is DR other. This is normal broadcast environment. See, show IP OSPF interface F00 will show you that. Broadcast. Now we are going to change this as non-broadcast. See what happens. Right now, when it is broadcast, the timer is 10 and 40. But I want to experience these points that I learned. Where's that? Yeah, these things like I want a neighbor to be manually configured, meaning no dynamic discovery of neighbor. I want this timer, blah blah. One more thing is, see, this is a default mode only if you have a frame relay environment. In our case, the default is broadcast. Now I'll go to F00 and say IP. I'll shut down the port for some time. Then I'll say IP OSPF network type non-broadcast. I'll also do the same on the other three. IP, OSPF, network type, non-broadcast. Also, I'll do the same on R4. All right. Shut down once and then I'll bring it up. So when I bring it up, the neighbor should not be discovered. The neighbor should not be discovered dynamically. Let me go to Wireshark and capture some packets in between. I'm not expecting any multicast, means OSPF multicast traffic now. Yeah, there's no hello packets. Nothing is going behind. So in a non-broadcast, we have to configure neighbor manually. How do we do that? We go under router OSPF and say, I have a neighbor called 10.0.0.4. This is the IP address of router 4 and also router 5. I have to give two neighbors. And then another neighbor is 10.0.0.5. Now, when you configure one side, the hello will go as a unicast. You see, where it is. It will come. The hellos will go as a unicast and form neighbor, not multicast. Let us also configure on R4. Router OSPF 1. Neighbor is 10.0.0.3. And another neighbor is 10.0.0.5. I'm not seeing any hellos. Interface F00, IP OSPF network type. I think we have already given non-broadcast. I need to now tell. Okay, it is doing ARP resolution. Let it resolve. Yeah, see OSPF has come. I need to say router OSPF 1 network 10.0.0 4N. Sorry, not network, neighbor. Yeah, 3. 4N 3. Okay, we can see that the hellos, let me show you hellos of OSPF. If I want to have hello, I need to make it as one. See, all the hellos here are unicast. 10.0.0.3 sending to 10.0.0.4, 10.0.0.4 sending to 10.0.0.3. You see, all the hellos are unicast here. Because we said non-broadcast as the network type, no neighbors are dynamically discovered because multicast is no more support. OSPF don't support. OSPF don't use that multicast address anymore. That's the right way of saying. And let us go see the timer now. You should see the timer shared here itself. In hello packets, usually they share the timer. You see, 30, 120. We can also see it on the router. Let's see on router 5 show IP OSPF interface F00. We can see the timer. Not only that, you can see the network type is not broadcast, just non-broadcast. And will there be DR BDR? Yes, there will be DR BDR. Let's check. Go to router 3 and try show IP OSPF neighbor. You can see router 5 is a DR, which means router 3 is a BDR. Let's go to router 4 and check the same command. Show IP OSPF neighbor. Show IP OSPF neighbor. Okay, 5 is a DR and 3 is the BDR. That's what we learned there. There is DR BDR election in non-broadcast. Okay, now let us go with this one. I'll go shut down those ports and change the network type. Interface F00, shut down. No IP OSPF network. Also on R3. No IP OSPF network. Also on R. Okay, I need to do in 5. Interface F00. No IP OSPF network. Shut down. All right. Now we are going to switch to another network type, point to multi-point. What are we expecting when we change to point to, yeah, no PDR, TR, and then neighbors, dynamically discovered. Let's go check. Wireshark is still running behind. Yep. Now let me go change one by one. I'll start from router 5. IP OSPF network type point to multi-point. I repeat the same on all the router. And then I bring the interface up. You will start seeing multicast traffic at the background. You see 224.0.0.5 started coming up. OSP follows or sent us multicast, which means the neighbors are dynamically discovered. All right. Still the negotiation is going. Okay, finish. Negotiation is over. All right. The hello packet's only going to be multicast. All the rest are going to be unicast. Let me show you some hellos now. Oh no, I want to show you the latest hello. Latest hello you see all 224.0.0.5. Yeah. All right. But I can still see some unicast hello. You know, the reason is I did not remove that neighbor statements from the router OSPF command. That's a mistake I did. You see, I went to each router, last network type. I've configured neighbor. I still didn't remove I have not removed this. That's why sometimes you can see some unique aspect. Otherwise, there will be only multicast hellos. Oh no. I did not clear it properly. That's why. So I'll shut down one more time the interfaces. 5. Interface F00 shut down. Shut down. Okay. So when I now unshut the interfaces, I should get the proper expected outputs. I'm going to open the Wireshark freshly. I'll stop this. A fresh capture. Done. Now I'm unshutting all the interfaces. We should see only multicast hellos. Okay, I'm waiting for the. See, still the ARP is resolving the MAC addresses of the neighbor from each router. ARP is sent to a broadcast address layer 2. See, these are all layer 2 source and layer 2 destination, layer 2 broadcast. These are ARP replies are unique. Okay, fine. Now OSPF has formed a neighbor. I can see acknowledgements flying to and fro, updates. Now let's see the hello packets. All the hellos, no, from 3 to 4. A unique hello is going. How come? Route 3. Show run section router OSPF. Nothing. Whatever, fine. To show run section. Okay. Okay, now it's only multicast. I don't know how the 2 packets were unicast. Hello packets are usually multicast. Okay, now where are we? Done. We have done 2 point to multipoint. What we go next is point to multipoint non-broadcast, which is available only on the Cisco device. So once again, I shut down all the ports. And what we do next is we change the network type. IP OSPF network type point to multipoint non-broadcast. Just in one line all together. Whatever we have seen so far. Point to multipoint and non-broadcast together. I repeat the same on the rest of the routers. And what do we expect? Neighbors must must not come. That's the best of the first one, non-broadcast. And the best of the second one is this one, point to multipoint, no DRBDR. This is what our expectation is. Now let's go. No shit. When I say no shit, the neighbor should not come. I should not see any hello packets sent between. I'm seeing some broadcast, sorry, ARP resolving MAC address, but why? Anyway, if we don't get OSPF, that is, oh, what? No. How is this? Am I doing correct? Point to multipoint non-broadcast. Okay, I say correct. Show run section router OSPF. Okay, looks good. Show run interface F00. Okay, this is also looking good. Point to multipoint on broadcast. Let me put this same command on other routers. Okay, correct. All right. And how the neighbor has come. Okay, there is no DRBDR we can see here. As we learned, there should not be DRBDR. But the neighbors are manually configured. That is how it should be. In the frame relay environment, we used to have this mode in frame relay, but in broadcast, it learns. That is what I can see. In broadcast, it learns, and the hello packets are unicast. In broadcast environment, it uses the multicast address, learns the neighbor. Once it learns the neighbor, it starts doing unicast hellos, not multicast hellos. It's same like what I used to do when I manually configure, no? What it used to do when I manually configure. Similarly, it starts sending hello, but the discovery of neighbor was initially by using, oh no, right from the beginning it is using unicast. But how it knows the neighbor's address? Surprise. ARP is sending who is 10005 and 10003. How it knows 10005 as a neighbor without sending hellos? And the hellos are multicast. Sorry, unicast. I think there should be some buffer, something on the routers based on the previous scenario, the neighbor addresses which might have been used. So what I'm going to do this time is I'm going to shut down the port, refresh all the tables, because it's not possible. It shouldn't. It should not discover. Should not discover dynamic. Okay, I would like to clear the OSPF process on all. Clear IP OSPF process. Clear IP OSPF process. Now show IP OSPF neighbor. Aha. This is what made that neighbor discovery happen. It's keeping this in the buffer. Clear IP OSPF neighbor. Do I have table? Events counters process. OSPF process 1. Show IP OSPF neighbor. This table should be removed. Only then what the result what we expect will come. If we restart the router, then you will not form neighbor. We have to configure neighbor manually. So there's no other go. I cannot wait for this to refresh. So I'm going to restart. Okay. I think the interfaces are down. I have to go unshut. Show IP OSPF interface brief. Okay, the F00 is shut down. I'll say interface F00, interface F00, no shut. Also here interface, also here. Right, I'm not expecting any ARP now. What is this gratitude ARP is coming? From where it got info? Let me see. Show IP. Gratitude ARP is no way related to OSPF. That is like, voluntarily someone is saying this is my IP address and MAC address. Show IP OSPF. Neighbor. Oh, good. This time it won't come. Unless we specify the neighbor manually, the neighbor is not going to come. This is the third type, and this is Cisco proprietary. The other two is broadcast and point-to-point, which we can try on the frame relay. We know what is broadcast, we know point-to-point normally, but this is over the frame relay having point-to-point experience, having broadcast experience. For this, we need to simulate frame relay, which we'll do in the next class, right? So let us now configure neighbor manually and see the result before we go. Router OSPF1, neighbor is 10.0.0.5, neighbor is 10.0.0.4. Router OSPF1, neighbor is 10.4, neighbor is 10.0.0.3. Also on router 4, see ARP is going down. Router OSPF1, neighbor is 10.0.0.5 and 10.0.0.3. That's all. Neighbor has come. It is unicast. None of the hello packets will be multicast. It's all unicast. All the hellos are unicast. They don't use multicast.